section, alveolar gas exchange. So we're looking in those tiny little sacs. The alveoli are the only place in your lungs that exchange actually takes place. Air travels through your trachea, it travels through your bronchi, your bronchioles, but your alveoli are the only place in your lungs where that exchange actually takes place. So the alveoli, we've looked at diagrams of these already, are the tiny little sacs that are clustered at the end of those alveolar ducts. So this picture you have prior, I've pointed it out before, but these, because I talked about pomegranates already, it looks like these alveoli look like little seeds that sit around this sac that leads to the duct. So the alveoli are these tiny little round parts where gas exchange actually takes place. Respiratory membrane consists of simple squamous, remember from beginning of the year, one layer, flat cells. The reason they are simple squamous is because they are thin and flat, then diffusion happens very easily. Endothelial cells, here again, simple squamous, are part of the capillary, and then the two basement membranes basically fuse together. Gas exchange then occurs across this area. So the respiratory membrane is this. I have my thin layer on an alveoli, one of those little sacs. I have a thin layer on my capillary, which is part of my blood system. So the air leaves my lungs and goes into the bloodstream at the respiratory membrane. That's where the actual crossover from your lungs to your bloodstream takes place. So this diagram we haven't looked at yet. So every little alveoli is surrounded by a capillary. So thin layer around the alveoli. The capillaries we talked about last chapter, very thin. So this is where oxygen leaves the lungs, enters your bloodstream. Carbon dioxide waste from your cells comes back, and then the carbon dioxide will leave your lungs. The oxygen will be carried to the cells of your body. And there's just another picture. I actually like the other one better. Gases diffuse. Diffusion is going from higher concentration to lower concentration. Gases in your respiratory membrane are going to diffuse from higher pressure to lower pressure. So kind of back to your inspiration and respiration. In a mixture of gases, here's a chemistry, partial pressure. If you talk about gas laws, you've probably heard this term before. In a mixture of gases, each gas has its own part in the total pressure. The amount of pressure each gas contributes is its partial pressure. So we talk about atmospheric pressure, 760 millimeters of mercury. Well, if you look at your atmosphere, most of the gas is nitrogen. There's carbon dioxide, there's oxygen, there's water vapor, there's hydrogen, there's, did I say water vapor? Yep, already. So we have all of these different gases. Each gas contributes to that total of 760. So obviously nitrogen, because it's the most abundant, is going to have the highest partial pressure. When the partial pressure of specifically oxygen is higher than in the capillaries, oxygen will diffuse into the blood. So when I get to that respiratory membrane, if my oxygen concentration is higher in my lungs than in my blood, it's going to go from higher to lower. It's going to go from my lungs to my bloodstream. When the partial pressure of carbon dioxide is greater in the blood than it is in the lungs, then carbon dioxide is going to go from the blood to the lungs. So wherever the pressure is greater, it's going to push or cross to where it's lower. There's other factors that help to increase diffusion. Surface area, and that can even deal with the size of your lungs, the volume of your lungs. Shorter distances are going to allow diffusion to happen faster. Solubility of gases. Oxygen is actually a little more soluble than carbon dioxide, and things like that. So here I can actually see some examples. So here's my pressure of oxygen. It's 40, it's 104. Where's oxygen going to go? Higher to lower. So my oxygen is going to leave here and go into my blood. Here my CO2 is 45. Here my CO2 is 40. It's going to go from higher to lower, and that's how that works. And I'll stop there.